All right, so concept 2 is the properties of logarithms. So this whole unit is about exponential functions and logarithmic functions, and they're inverses of one another. So the whole reason why you would use logarithms in the present day is if you're trying to solve for a variable that's in the exponent. So there's a lot of different applications of exponential functions. You can use them to study population growth, bacteria growth, compound interest, like the problems that we just saw. There's a lot of applications in science. So we'll talk a little bit about those during our in-class time. For this screencast, let's talk about the properties of logarithms so that we can actually use logarithms to solve those other types of application problems. So like I said, exponential functions and log functions, they're inverses. So they undo one another, just like multiplication undoes division. So when you are evaluating a logarithm, you're solving for the exponent. So this page in your notes, page 2, is excellent. It summarizes everything that you could ever want to know about the rules and properties of logarithms. So slowly read through this because we'll see these properties when we solve the logarithm equations. We've got log form and exponential form. So the most important thing is being able to switch from one form to the other. So right here, log base b of x is 11. If I want to rewrite that, my base is b, my exponent is y, and whatever you're taking the log of, that is what it would be equal to. So b to the y power equals x. Now on your calculator, you'll see a button for log base 10. It says LOG, and then you'll see a button for the natural logarithm, base E. Base E logarithms are heavily used in calculus. So when you're working with logarithms in calculus, you'll encounter base E a lot. And base E just means that your base is E on that logarithm. You'll see it written as ln, but you could also write it as log with the tiny e for the base. But usually you just write ln. All of these rules here, so for example, if I rewrote this in exponential form, I would have b to the 0 power equals 1. Anything raised to the 0 power is 1. All of your log rules are traced back to your exponent rules from Algebra 1 because a logarithm is just an exponent. So again, read through these. We'll talk about them a little bit more in our in-class time. The laws of logarithms, you've got your product rule, your quotient rule, your power rule, and my favorite, the cancellation rule. So when we condense logarithms, if you're adding two logs together, you can condense them by writing the word log once and multiplying what you're taking the log of. If you are subtracting two logs, you can condense by writing the word log once and writing the quotient, the ratio of what you're taking the log of, so m over n. The power rule is if you're taking the log of something raised to a power, the power can then become the coefficient, the multiplier in front of the logarithm. And the last rule here, if you have a log equal to a log, and they have to be the same base, and you only just have one log on each side of that equation symbol, you can cross out the logs and set what you're taking the log of equal to one another. Change of base is on the newer calculators. This formula is already programmed in, so I'll show you that in class. But here's your change of base. Basically, you have buttons for base 10 and base E on your calculator. This is how you can find or evaluate the logarithm of any base. All right, so switching forms. So let me see if my video loaded. I don't think that it did. So I'm going to stop this and I'll try, see if it loads.